Yo, FSD, what's going on? We're going to continue chapter 11 today. Today, we're going to be talking about theoretical and experimental probability. Okay? Really, it shouldn't be too bad. I think you'll see that after chapter 8, things lighten up a little bit. So let's go ahead and get started. The warm up question for this, I'm not going to go over the warm up questions today. As you can see, there's a whole lot of them. All these questions are all just permutation, combination, fundamental counting principle questions. Your PowerPoint for this is posted on Canvas. So if you have any questions, ask your teacher. But here we go. Let's go ahead and get started. I'm going to try to make these videos short so you guys can, hopefully you're not watching them too long. All right. But here we go. So we're going to do 11.2, theoretical versus experimental probability. All right, so first off, we have some vocabulary that you should probably know. If you want, you can pause the video right now so you can write all this down if you want. Also, this is posted on Canvas. You don't have to. But essentially, probability is the measure of how likely something is to occur. So if I toss a coin, what is the probability that it lands on a heads, right? We'd think, okay, well, 50%, right? An outcome is what happens after you do that experiment. So your outcome of tossing a coin, it could be either heads or tails. Your sample space is all the different outcomes that are possible. Okay, so if I randomly pick a month in the year, your sample space would be all the different months in a year. Okay, and an event, that's kind of like your trial. It's your, the tossing of the coin or something like that. But this is just some vocabulary. You're not really gonna, have explicit questions on this. This is just, I'm gonna be using these terms a lot. So you wanna know what this means. But here we go. This is just kind of showing the vocabulary in use, right? So we have a probability experiment, rolling a die or a six-sided number cube, however they wanna say it. Your possible outcomes, you could roll a 2, you could roll a 5, etc. Those are all the different outcomes that exist. Your sample space, if you see as 1, 2, 3, 4, 5, 6, those are the 6 different numbers on your number cube. And the event, oh, okay, maybe you roll a 6. Okay, so not too bad. Again, I don't think this section is as bad as chapter 8. I know chapter 8 is very difficult. We're going to skip that slide because we don't need it. Okay, so theoretical probability. Okay, you're going to want to write this down right here. Okay, the probability of an event occurring, you take the number of favorable outcomes in the numerator over the number of outcomes in the sample space. This is called theoretical probability because it is exactly that. It is theoretical. Okay, it's what you think would happen. Is that necessarily what's going to happen? No, but it's what you think would happen. So we have this kind of experiment right here. Imagine that you toss the same coin 20 times. How many times would you expect to land on heads? Well, we'd think it'd be about half the time, right? So theoretically speaking, it should land on heads maybe 10 times. Okay, so that's what we're talking about, theoretical probability. All right? So let's do some really basic examples. You roll a die. What is the probability that you roll a 5? Well, if we remember, probability of our event, rolling a 5, is equal to the number of favorable outcomes over the possible outcomes. Well, how many possible outcomes are there if I roll a die? Well, there's 6 different outcomes, right? I could roll a 1, 2, 3, 4, 5, or 6. Well, how many ways can I roll a 5? Well, if I'm just throwing one number cube, there's only one way I can roll a 5. So the probability, when you read this, the probability of rolling a 5 is equal to 1 over 6. That's it. It's not too bad. All right? How about this one? What is the probability that you roll an even number? Well, probability of an even number. I know there's 6 outcomes on a die, right? Roll the dice, 6 outcomes. How many of those are even? Well, a 2 is even, a 4 is even, and a 6 is even. So that's 3 out of 6. The probability of rolling an even number is 3 out of 6. which we should reduce to 1 over 2, which makes sense because half the numbers on the dice are odd, half are even, so it makes sense that we have a theoretical probability of 1/2 or 50% or however you want to say it. All right, doing good so far. Careful with your wording here. What is the probability you do not roll a 4? Well, let's go ahead and write that. Probability of not rolling a 4. Well, there's still 6 possible outcomes. And if I'm not rolling a 4, that means my favorable outcome is rolling a 1, 2, 3, 5, or 6. So that's going to be 5 out of 6, and you're done. And that's really all theoretical probability is about. Okay, we're going to move on to what's called the complement rule, which goes along with this kind of example right here. So the complement rule is what we're saying here is we're saying, look, if the probability of an event is occurring is this amount, then what's the probability of the event not occurring? And all we do is we take the probability. So if I want to find the probability of something not happening, we just do 1 minus the probability that it does happen. So I'll give you some examples. The probability that it's going to rain today is 20%. So what is the probability of it not raining? Well, that would be the other 80%, right? The probability of me rolling a 2 is 1 out of 6. So what's the probability of me not rolling a 2 would be 5 out of 6, the other part, okay? You don't have to use the complement rule, but it helps in some situations. I just kind of talked about this one, so I'm going to skip this one for now. Let's just do this. What is the probability of rolling less than a 5? Well, we don't even need to use the complement rule. If you want to, you can. I'm not going to. The probability of rolling less than a 5, well, that means I can roll a 1, a 2, a 3, or a 4. So probability less than 5 would be 4 out of 6, right? I can roll a 1, 2, 3, or 4. Let's go ahead and simplify that to 2/3. That's it. All right? That's it for theoretical probability. We're going to move on to experimental probability, which in my opinion is even easier. So check it out. Experimental probability is the same thing as normal probability, except that we are using the results of an experiment to calculate our probabilities. Okay? If you want to write all this stuff down, you can. You can always pause the video, right? But I'm going to keep moving on. So here we go. Here is the result of 100 rolls of a dice, or a die, or a number cube, or whatever you want to call it. What is the probability of rolling a 3? Well, how many total outcomes did we have? How many times did we roll that dice? Well, we rolled it 100 times, right? So out of 100 trials, how many times did we roll a 3? Well, if you look here, looks to be about 16. So according to this experiment, the experimental probability of rolling a 3 is 16 over 100. You can reduce that to 8 over 50, which reduces to 4 over 25. If you want to give this answer as a percentage, that's fine. If you just want to tell me the probability is 0.16, that's fine too. Okay? Probability of rolling an even number. Well, I have 21 2s, I have 11 4s, and I have 12 6s. And I'm just pulling those numbers from the graph. I'm just going to add those all up, and I'll get into and or if I haven't already. I honestly don't remember, but we'll get to that later. So 21 plus 11 plus 12 is I think 44. Let me just check in a calculator right quick. Yeah, 44. So 44 out of 100 you can reduce that however you want. Okay? Rolling number other than a 5, something like that, I would just count up how many 5s we have, which looks like it's 22 5s. And I'm going to do that complement rule. I'm going to go 1 minus 22 is going to be 78. So the probability of rolling a number other than 5 is 78 out of 100. You can reduce that and all that good stuff. I don't want to waste your time on a video. I think that's all we got for this video. If you have any questions, please reach out to your teachers. We are bored generally. If you have any questions, ask us. Okay? Good luck. We're going to be moving on to geometric probability next. Y'all take care now.